Okay, let's put all our knowledge together about rational functions by creating some definitions or just kind of this idea of the knowledges we came up with. And so the first thing we want to talk about is so we notice that this is a linear function, ax plus b, divided by another linear function, cx plus d. And so first thing we discovered is this idea of a vertical asymptote. And so the vertical asymptote, and actually do it in the color that we were working with to begin with vertical asymptotes. So our vertical asymptote breaks up the domain because the function becomes undefined when the denominator is 0. And this is because division by 0 is not possible. Okay, so the first thing we want to do is find the vertical asymptote to help us with the domain. So the vertical asymptote is found by taking cx plus d equals 0, and you solve for x. And so we end up with x equals some number, whatever that is. And because this breaks up our domain, so recall that our domain is left and right, and our domain starting out with any function is all real numbers unless we know that it gets restricted in some way. And in this case, the domain is going to get restricted at wherever this vertical asymptote is. So the domain of our function is always going to be all real numbers except x equals the vertical asymptote, wherever that value ends up. Okay, so that's what the vertical asymptote does for us. And then we learn that we can write a meaning statement. And again, there's always two parts to a meaning statement. There's the input value and the output value of any meaning statement. And so in our meaning statement, we know that as the input, whatever that input is, approaches the whatever the vertical asymptote value is, the function or the output. So the function or the output gets either really large or gets really small because something happens. So this all is related to the oil spill problem. So then we want to talk about the horizontal asymptote. And so our horizontal asymptote this is going to break up the range and this is something we haven't quite figured out why this is happening yet. So let's go back and look at this problem here, our part E, where we know that the horizontal asymptote is 3/2. And so we notice that the horizontal asymptote is getting closer. We cut closer and closer to this horizontal asymptote as the input values get really, really small or really, really large. So if, for instance, if I wanted to do f of, let's just say 100. And so now we have 3 times 100 plus 3 over 2 times 100 minus 1. So if we're thinking about money, we have $300 plus 3, so we have $303 divided by $199. But if we make this number get really large, let's now talk about 1,000. So now we have 3 times 1,000, or 3,000 minus or plus 3, over 2 times 1,000 minus 1. So now we have $3,003 divided by 1,999. If we get any larger, if we go $1 billion, so now we have 3 billion plus $3 and 2 billion minus $1. Notice how the 3 and the 1 start becoming very insignificant as the input values get larger and larger. So the 3 and the -1 actually become insignificant. They're still there, and that's why we never reach the horizontal asymptote, because these dangling pieces are still here. So they're still getting close to, but not there. And all that we're left with is looking at dividing the constant rate of change of the numerator by the constant rate of change of the denominator. And so so our horizontal asymptote breaks up the range because as the input values get really large or really small, the output values get closer and closer to that horizontal, that the numerator, the constant rate of change of the numerator divided by the constant rate of change of the denominator. So the input value goes really, really large or small. The output values either increase or decrease to get closer to the constant rate of change of the numerator divided by the constant rate of change of the denominator. And remembering that those little pieces at the end, the vertical intercepts of those two, these constant values, are still there, so we don't ever quite reach the vertical or the horizontal asymptote. So our our horizontal asymptote, running out of room here, is y equals constant rate of change of the numerator divided by the constant rate of the denominator. Oops. Yep. And we know that this means that now we have up and down, that's our range, and this would be all real numbers, except that now we're putting in this horizontal asymptote. So the range is going to be all real numbers except wherever that horizontal asymptote ends up, and that's y equals the horizontal asymptote. And one last thing is we want to talk about the meaning for this. So again, two parts, an input part and an output part. As the whatever our input is increases or decreases, the output, whatever our output is, also increases or decreases. Toward the horizontal asymptote value, but never reaches it.